Hello everyone, I'm Jay Joshi and welcome back to the third episode of Learning Java. Today we'll be learning about data types, variables, literals, and constants. So let's begin. Data types. Java has two types of data types, which are primitive data types and reference data types. We'll be going into their detail now. Primitive data types, also known as fundamental data types, are the inbuilt data types offered by Java. These include integral, fractional, character, and boolean. Each of these types, integral, fractional, character, and boolean, have various types. Like integral has byte, short, int, and long. Fractional has float and double. Character has char. Boolean has boolean. So we need to learn all of these different types of primitive data types, and these are the data types which we'll be using in our program. Integral data types. So integral data types, as I said, are byte, short, int, long. Byte reserves one byte, short reserves 2 bytes, int reserves 4 bytes, and long occupies 8 bytes. You need to learn these values as later on when we'll be converting from one data type to another, you need to know which one's the bigger one. So it's important to know how much bytes each data type occupies. Fractional data type, float and double. Float occupies 4 bytes and double occupies 8 bytes. Something important to note here is that float and int, although they both reserve 4 bytes, float is larger than int because the number of digits in float is more than that of int. Just understand that for now. Later on, you'll see the usage. And double is bigger than long because double and float they have decimal points, and integral data types they do not have decimal points. That's why fractional data types are bigger than integral data types. Character data type, which is char, and it reserves 2 bytes. Boolean data type, it reserves 1 byte but it uses only 1 bit. And for those of you who didn't know, 1 byte is equal to 8 bits. So here's the order which I was talking about. Boolean is the smallest, reserving only 1 byte and uses 1 bit. Then we have byte with uses only 1 byte, char 2 bytes, short 2 bytes, int 4 bytes, long 8 bytes, float 4 bytes, double 8 bytes. So this is the order of the data types, and it's important to learn this as later on, as I said before, we'll be converting data types from one to another. So we'll be implicitly and explicitly converting them. So it's important to know which is bigger. Reference data types are arrays and strings. We'll be covering this in a later topic as arrays and strings is a vast topic. Variables. A variable is a named storage location in the computer's memory. It can hold only one value, and its value can be manipulated during the execution of the program. Variables examples are like A, B, C, D, to which you assign a value, like int A is equal to 10. So the A is a variable, and you might have seen in the previous episode we talked about identifiers. So A is an identifier that can be any name. It can be number or no or anything. It can be anything, but it should not be a keyword. Declaration of variables. So to declare variables, first we need to specify the data types, which are the primitive data types, and then the name of the variable, which should be a valid identifier, which we discussed in the previous episode. Some examples are int a, string s, strings I said we'll be discussing in a later video, float f, double t, short v, boolean abc, char ch, and long l. So that's how you declare a variable. And note that I have written I, F, D, S, B, C, L. I've written everything in small letters, and that's very important as these are keywords. You cannot alter their case. You might have noticed in string, I've written the S as capital because that has to be there. So in strings, the S has to be capital, but in the rest, everything has to be small. Initialization of variables. So to initialize a variable, we need to assign it a value. So int x is equal to 3, double d is equal to 45.67. And please note that in int we cannot have decimal values. So int x is equal to 3.4. That'll be wrong. The compiler will give an error. If you want a decimal, you have to use either float or double. Char ch, which should be enclosed in single quotes, and there should be only one letter, digit, or symbol in char. String should be enclosed in double quotes, and it can be how much ever long. It can be alphabets, digits, symbols, anything. And int y, we can see the variable being declared, and when we say y is equal to 100, we initialize that variable. So we give that variable y, which is an int, a value which is 100. Something to note here is that I have put a semicolon, which I have not discussed before. So after every line in Java, you have to put semicolons. There are some exceptions, like in for loop, which we'll be covering later. So you have to put a semicolon after every line you write in Java. Constants. Constant basically means what it says. A constant is a variable whose value cannot be changed once it has been assigned a value. The value remains constant. So how do you make a variable constant? We use the keyword final. So to make int I is equal to 101 a constant, we need to add the final keyword. So we'll write final int I is equal to 101, and then you put a semicolon. Note that in final everything is small, and for double we can write final double t is equal to 244.2. This applies for everything, even character, boolean. So you might be wondering, why do we need constants? What's the use? I get it, don't need to change the value, but how's that going to help? So let's see that. The advantages of constants. So when we are reading the program and we use the final keyword before a declaration or initialization, it will indicate to the programmer or anyone who reads the program that that value cannot be changed. So this will make it easier to read the program and check for correctness. Also, if we need to change the value in the constant, we need to only change the declaration. But instead, if we use the literals are data items that are fixed data values. Example 4, 5, 6, it can be any number. If we use a literal, we have to change that every specific occurrence. So that's the advantage of using a constant. Suffixes. Suffixes is a bit difficult to understand in the beginning, but later on when you start programming, you'll get the hang of it. These are used to explicitly specify the data type of a literal data value. So we have two types of suffixes, F and L. We can write them in lowercase and uppercase, it doesn't matter. So why do we need suffixes? Think of it this way. Let's say I declare something as float pi is equal to 3.14. Now, what Java does internally, as you know, I said before, double is bigger than float. Float has only 4 bytes and double has 8 bytes. So Java, for some reason, it considers float pi 3.14 as a double, and it says that there'll be possible loss of precision. So what that basically means is in double we can have around 20 digits, and in float we can have about 10 to 11 digits. So Java internally takes the float pi 3.14 as a double. So it says that there might be loss of precision. So when you'll be writing big programs, it's important that we don't lose data. So there'll be loss of precision. So to tell the compiler that we want it as a float, you put an F after the value, which is 3.14. So as you can see, we put an F, and this will indicate to the compiler that the variable is a float data type and not double data type. So as you can see in this example, long L is equal to a huge number. So what Java does is internally it assumes every long data type to be an int, and it says that the number is too large. As I said before, long reserves 8 bytes and integer only reserves 4 bytes, and this number cannot fit in an integer. And so Java gives an error saying that number too large to be integer. So we need to explicitly specify the data type by using the suffix small l or capital L, and as you can see, we have put it here. So that's it for everyone. Thanks for watching. If you have any queries, suggestions, or you would like me to cover a specific topic, you can mail me. My mail will be in the description below. And thanks everyone for watching.